In this video, I'm going to cover how we're going to rewrite expressions that have negative exponents in them into expressions that have positive exponents in them. And this is going to effectively make it easier for us to reduce the expression and simplify it as much as we can. So let's go into an example. Let's say I have a squared over b to the negative second power. So the rule for negative exponents, well, there's a few of them, but one of them states that if you have some number raised to the negative exponent, this is the same as writing 1 over that number raised to the positive exponent. And then when you use the fact that we could distribute the exponent to the top and bottom of the fraction, this is the same as writing 1 over a to the m power. And this works the same way if you have a fraction that has a negative exponent on the bottom. So if I have 1 over raised to the negative m, this is the same as writing that number raised to the positive power, which is just a positive power. So essentially, I'm just working backwards here. So using that fact, I can rewrite the b to the negative second power on the bottom as just b to the second power. So this expression simplifies into a squared times b squared. Let's say I had the expression a squared times b to the fourth multiplied by 3a times b to the negative second power. So I can use the properties of exponents that I had before in order to carry out this operation and get it into one singular term. So I have a 3 and an implied coefficient of 1. So 3 times 1 gives me a 3 out in front. And then a squared times a gives me an a cubed. And b to the fourth times b to the negative second gives me a b to the second power. Because again, whenever I do some number times an exponent multiplied by that same number raised to another exponent, it's that number raised to the sum of the exponents. And in this case, we have b to the fourth times b to the negative second. So this is the same as writing b raised to the 4 plus negative 2, which is just b squared. So that's where the b squared comes from. Let's say I had the expression 6 squared times u to the third power times v to the negative third power divided by 12 times u to the negative second power times v. So first of all, I can write 6 squared as 36. And 36 over 12 is just 3. So what I'm left with is I'm going to have a 3 u cubed times v to the negative third power divided by u to the negative second power times v. And so you can go about this one of two ways. You can either use the quotient rule and say that u cubed over u to the negative second is equal to u raised to the third power minus negative second, which gives me u to the fifth. And that takes care of the u's. And then I can also say that v to the negative third power divided by v is the same as v raised to the negative third power minus 1, which is just v to the negative fourth power. So if I apply these, I end up with 3 u to the fifth power times v to the negative fourth power. And then if I want to move this negative fourth power and convert it into a positive, I can rewrite it as 3 times u to the fifth divided by v to the fourth power, using the first rule that we learned about negative exponents. Let's say that I had 3 raised to the negative 4th power times m raised to the negative 1st power times n raised to the negative 3rd power divided by 9 raised to the negative 2nd power times m times n raised to the negative 3rd power. So right off the bat, I can see that I have an n to the negative 3rd on top and on the bottom, so they cancel. Then I'm left with 3 to the negative 4th power times m to the negative 1st divided by 9 to the negative 2nd power times m. So in order to get rid of the negative exponents, all you have to do is switch what side of the fraction that they're on. So to write these as positive exponents, I just switch top and bottom all of the things that have negative exponents. So when I do that, I end up with a 9 squared on the top and 3 to the 4th times m squared on the bottom. Now 9 squared gives me 81, and 3 to the 4th is also 81. So they end up canceling. And then my final answer is going to be 1 over m squared. Let's say I have the expression 5a raised to the negative 2nd power divided by 5a raised to the 2nd power. So since we have the same base on top and bottom, I'm going to use the quotient rule. So this is equal to 5a raised to the negative 2nd power minus the 2nd power, which is the same as 5a raised to the negative 4th. And to rewrite that as a positive exponent, I place it on the bottom of the fraction. So this is the same as me writing 1 over 5a raised to the 4th power. And now this is fully simplified. Another way to do this is by putting the numerator with the negative exponent in the denominator first, so that you have 1 over 5a squared times 5a squared. And of course, this also just gives you 1 over 5a to the 4th power. Let's say that we had 4 times x to the negative 1st power raised to the negative 3rd power divided by 4 to the negative 2nd power times x to the negative 1st power raised to the negative 1st power. So I can move this 4 to the negative 2nd power to the top by just switching which side of the fraction it's on. So I would have 4 squared times 4 times x to the negative 1st power raised to the negative 3rd power divided by x to the negative 1st power to the negative 1st power. And this gives me 64 times x to the negative 1st power raised to the negative 3rd power times x to the negative 1st power raised to the negative 1st power. And I can use the fact that if you have some number raised to a power and you raise that to another power, then that's just the same as that number raised to the product of both of the powers. So if I apply that to top and bottom, I end up with 64 times x to the 3rd power over x to the 1st power. And then I can use the quotient rule to reduce this fraction. So one of the x's on the top cancels with the one on the bottom, and then I'm left with 64x squared as my final answer. Let's say that I had x plus y to the negative 1st power to the negative 1st power. So I can rewrite this with positive exponents by placing it on the denominator of a fraction. So this is the same as writing 1 over x plus y to the negative 1st. And then when I want to get rid of the negative 1 exponent for the y, I can rewrite this expression this way. So this is okay, but you can rewrite this in the following way if you want to combine the two terms on the bottom. Leaving it this way is completely fine though. So to combine the two terms, I can interpret this as x over 1 plus 1 over y. And when I combine the two fractions, I end up with xy plus 1 divided by y. And then to rewrite this into a singular term, I have y over xy plus 1. So both of these answers will work because they mean the same thing. Last example here. So let's say I have x to the negative third power over y multiplied by x over y to the first power, or to the negative first power. So what I can do is rewrite the first expression like this. So I have 1 over x cubed times y. And I can rewrite the second expression with positive exponents by just flipping the two numbers in the fraction. And then when I combine these together, I just multiply across the top and across the bottom. So what I end up with is y over x to the fourth times y. Then the y's on top and bottom cancel each other out. So my final answer is 1 over x to the fourth. So I hope this video was helpful in learning some of the rules surrounding negative exponents and a further review of the basic exponent properties that we use. So we use that in conjunction with the order of operations, PEMDAS, and also the rules for ordinary exponents to come up with our simplified expressions. Thanks for watching, and I will see you for the next video.